You know, there's a force of nature that travels at the speed of a jet plane, but it crosses entire oceans almost completely unseen. It's powerful, it's deceptive, and today we're going to pull back the curtain on the tsunami, the silent giant of the deep. Take a look at this number, 227,899. That's not just a statistic. It's the number of people who died in one single event, the 2004 Indian Ocean tsunami. It's a number so huge it's almost impossible to wrap your head around. But behind it are real people, real stories. Listen to this. This is from Azara Liusa. She was just 10 years old when the waves slammed into her home in Indonesia. And just like that, her words take us from a massive abstract number to the sheer terror of what it felt like on the ground. So, to really understand that devastation, we've got to go back. We need to trace this giant wave all the way back to its source. We'll start with the aftermath and try to answer the question, what in the world can cause this much destruction? Yeah, you heard that right. The 2004 tsunami wasn't just a local disaster. Its destructive power reached 17 different countries. Think about that for a second. From Southeast Asia all the way to the east coast of Africa. So, what could possibly do that? Well, the story doesn't actually begin with a wave. It begins deep, deep down on the ocean floor, with a sudden, violent rupture. This is the moment a tsunami is born. Okay, first things first, let's get something straight. A tsunami is not a tidal wave. They're totally different. Tides have to do with gravity from the moon and sun. A tsunami, which literally translates from Japanese as harbor wave, is all about displacement. It's a massive, sudden shove on an unbelievable amount of water. So what's doing the shoving? Well, most of the time, the big culprit is a giant undersea earthquake. We're talking about 75% of the time. You get these tectonic plates that shift violently, one shoving up or dropping down, and it displaces the entire column of water sitting on top of it. Other triggers can be huge underwater landslides or even really violent volcanic eruptions, but earthquakes are definitely the main driver. So once all that energy gets transferred into the ocean, the tsunami starts its journey. And this is where the whole thing gets, well, it gets fascinating and honestly terrifyingly sneaky. Just look at this comparison. A regular wave that you see at the beach, that's just a surface thing caused by wind. A tsunami is a completely different beast. Its energy goes all the way down to the seafloor. It's moving at 500, maybe 600 miles an hour, jet plane speed. And its wavelength, the distance between one wave crest and the next, can be hundreds of miles long. It's just staggering. But wait a minute. This brings up a huge question, right? If you've got this unbelievably powerful wave moving at the speed of a jet, why can't you see it? Why can a boat just sail right over it in the middle of the ocean without even noticing? And here's the crazy answer. Because that energy is spread out over such a massive wavelength, in the deep ocean, the wave itself might only be a meter high, like 3 feet. It's practically nothing. I mean, get this. During the 1896 Sanriku tsunami in Japan, fishermen were out at sea, just 20 miles from shore. They felt nothing, maybe a gentle swell. They came back to find their villages completely gone and 28,000 people lost. They had no idea what had just passed underneath them. So this silent, stealthy journey across the deep is really just the beginning. The real danger, the true horror, starts when that tsunami gets close to the coast. This is where the transformation happens. The science behind it is a process called wave shoaling. The simplest way to think about it is this. All that energy that was moving forward at incredible speed suddenly runs out of room. And when it runs out of forward room, there's only one way for it to go, and that's up. So let's break it down. As the front of the wave starts to feel the seafloor getting shallower, it starts to slow down because of the friction. But the rest of the wave, maybe hundreds of miles of it, is still screaming along at 500 miles an hour. It's like a massive traffic pileup. The water has nowhere to go, so it starts to compress and stack up. And that's what makes the wave's height absolutely explode. This chart shows that trade-off perfectly. Out in the deep ocean, you've got insane speed but a tiny height. Then, as it gets near the coast, the speed plummets, but the height just skyrockets. That invisible little swell becomes a terrifying wall of water. And it doesn't just crash and pull back like a normal wave. It just keeps coming, like a massive, fast-rising flood that swallows everything. Understanding this whole journey, from a little tremor on the seafloor to a coastal catastrophe, it isn't just a science lesson. It is literally the key to survival. And we need to understand it because this is not a new threat. Just look at this list. From the 2011 disaster in Japan all the way back to Portugal in 1755, and even centuries before that. Coastal communities have always lived with this risk. History shows us it's not a question of if the next one is coming, it's a question of when and where. And that is exactly why this all matters so much. Every piece of this science, detecting the earthquake, modeling the wave's path, predicting when it will hit, all of that fuels the warning systems that can give people those crucial minutes or hours they need to get to higher ground. It's what shapes the drills and the public education that can literally be the difference between life and death. Which brings us full circle, back to Azara Layusa. 20 years after she was that terrified 10-year-old, this is what she says now. She's not a helpless victim anymore. She's a prepared citizen. That one simple sentence shows this incredible journey from trauma to understanding to taking action. It's a lesson born from unimaginable loss, but it's a lesson of hope. Because the science on this is crystal clear. The Earth's plates are going to keep shifting, the ocean is going to respond, the silent giant will wake up again. So the only real question left for us is, are we ready? Have we truly learned the lessons from its past?